Next up, we have proportional shapes. Now, I do think knowing dimensional analysis definitely helps in understanding this concept. So I do have a throwback question here. A town has an area of 2 square miles. What is the area in square yards of the town? Now they give us 1 mile is equal to 1,760 yards. But if you notice in the question, it says it in square miles and square yards, whereas this is only normal miles and normal yards. So we can't actually use this yet. First, we have to convert this equation into square miles and square yards. To do that, all we have to do is just square the entire equation. After squaring it, you get that 1 mile squared is just 1 square mile, and that 1,760 yards squared is 3,097,600 square yards. Now that everything is converted, we can just multiply this by 2 to get 2 square miles. And then that we get that the area in square yards is 6,195,200 square yards. So the important thing here was that we had to square the equation first before we could do anything, because they wanted it in square miles and square yards. Moving on to actual proportional shapes, we do have two shapes here. We have square A and square B. Square A has a side length of 2 centimeters and an area of 21 centimeters squared. Square B has a side length of 6 centimeters and we don't know its area. So we do get a few bits of information from here. The first one is the area, and we also know the side lengths. Then we also have two shapes. We have square A and square B. I think you can see where I'm trying to go with this. We're setting up a proportion. First things first, the area of square A is 21 centimeters squared, but we don't know the area of square B. So I'll just label that as X. Then the side length of square A was 2 centimeters, and the side length of square B was 6 centimeters. Now before we move on, I'm going to simplify this fraction. 2 over 6 is just 1 over 3. And then we can cancel out the centimeters, leaving us with 1 over 3. Then I'm going to bring down the area. But before we also bring down the length, you have to notice that the area has centimeters squared. Whereas in the length, it was just centimeters. So to get to centimeters squared, we have to square this fraction. 1 squared is just 1. And 3 squared is just 9. So our fraction will be 1 over 9. Now we can just cross multiply, and we get that x is equal to 189 square centimeters, or centimeters squared. Wait, I don't even know. You know what, it doesn't matter. Alright, so our answer is that the area of square B is 189 centimeters squared. The important thing to get from this was that we had to square this fraction here before we could actually set them equal to each other and cross multiply. Just like in that dimensional analysis example, where we had to square that entire equation to get that conversion factor. Alright, that was the super broken down step-by-step version of it. But of course, there is a formula that you can use. And it's gonna be the area of the first shape over the area of the second shape is equal to the length of the first shape over the length of the second shape squared. Now this also works for volume. If you're looking for volume, all you change is that you're going to be cubing it instead of squaring it. Now the reason for this is because if you say the volume something, right, you're going to say 300 cubic meters, and you have that word cubic right there, right? So you have to cube it, you know what I'm saying? And then if you have area, you say it's 300 square meters, so you have that word square, so you got to square it. Yep. Anyways, this length part, it can mean the side lengths, it can mean the radius, or it can mean the perimeter. Now that we have our formulas, let's try doing another example without working it out, so like step by step. Let's just plug it into the formula. Circle A has a radius of 8x, and circle B has a radius of 12x. How many times larger is the area of circle B compared to circle A? Here they're asking for area, so we're going to be using our area formula, which is this. They don't give us the area of the circle A or circle B, but they do give us the length. Well, they give us the radius. So I have 8x, and we also have 12x. Plugging that in, we get this. There's no space left, so I'm going to move to another slide. Alright, first thing we're going to do, I'm going to simplify this fraction. If you really wanted to, you could square it. It doesn't really matter. 8x over 12x simplified is just 2 over 3. Now we're going to square it, and you get 4 over 9. Now that it's all by itself, you can cross multiply, and you get that 4 times the area B is equal to 9 times the area of A. Now if we quickly look back at our question, it's asking how many times larger is the area of circle B compared to circle A. So we want to get the area of circle B by itself. That means we're going to have to divide this by 4 to get area B by itself. And we get that area B is equal to 9 over 4 area A. So area B is 9 over 4 or 2.25 times greater than area A. So with proportional shapes, the really important thing is to just remember whenever you get this side ratio of the side lengths, you always have to square it.